Ready for a deep dive today? We're going to be exploring quantum-inspired algorithms.
Which,
It's a fascinating area.
it is.
Sounds complex, I know, but
It's surprisingly intuitive,
oh,
actually.
really?
Yeah, it is. Think of it like trying to find the highest peak in a mountain range, but you don't have a map. You would just kind of explore, try different paths, and hopefully you'd reach a peak that's, pretty high up there.
Right, right.
Metaheuristics work in a similar way.
So instead of perfect, we're aiming for really good, really fast.
Exactly. Yeah, especially for complex problems where finding the absolute best solution would take, well, forever, basically.
Okay, that makes sense. But where does the quantum-inspired part come in?
So it's about taking inspiration from quantum mechanics. Like
Okay.
imagine harnessing the strangeness of quantum phenomena,
Okay.
like superposition,
Right.
where something can be in multiple states at once
Right.
to supercharge those algorithms.
So it's like a quantum computer being able to explore tons of different possibilities at the same time.
Yeah.
Exactly.
Wow. And the best part is we can run these quantum-inspired algorithms on regular computers right now.
Yeah, absolutely.
We're already seeing potential in fields like logistics,
Oh, yeah.
optimizing delivery routes, maybe making airplanes even more efficient.
Absolutely. And that's just scratching the surface.
Really?
Yeah. One type of quantum-inspired algorithm that I think really showcases this potential is the genetic quantum algorithm, or GQA.
Genetic, like breeding algorithms.
Essentially, yes.
Wow.
You can think of it as a population of potential solutions, each like an individual with unique traits.
Okay.
And these GQAs use principles borrowed from both genetics and quantum mechanics to evolve those solutions over generations, making them better and better at solving a particular problem.
So instead of genes, we've got algorithms that are learning and evolving.
Exactly, yeah.
That's amazing. How does it actually work? What makes them so different?
So it all comes down to how they explore solutions.
Okay.
Remember superposition, that ability to be in multiple states at once.
Yeah. GQAs leverage this by using quantum chromosomes.
Okay.
So instead of just zeros and ones, like in traditional computing, these chromosomes use qubits,
Right.
which can be both 0 and 1 simultaneously.
Okay, so instead of just two options, it's like each qubit can explore a whole range of possibilities at the same time.
Exactly. That's the beauty of it.
That sounds incredibly powerful.
It is. It's like having a whole team of explorers searching for the best solution in parallel, rather than one explorer going down a single path.
Right, right.
This allows GQAs to explore a much richer set of solutions, significantly increasing the chances of finding, well, the best possible outcome.
It's a game changer, especially for complex problems where traditional methods might get stuck.
Yeah, absolutely.
So how do these GQAs actually improve and refine these solutions over time?
They use two key procedures: make and update.
Okay.
Think of the make procedure as a way to introduce new potential solutions into the mix,
Gotcha.
adding diversity to the population. And then the update procedure, that's where the quantum magic really kicks in.
Okay, break down this quantum magic for me.
So this is where the algorithm simulates quantum effects to evaluate and refine those solutions. It's like guiding the evolution of those quantum chromosomes, pushing them towards a better and better outcome with each generation.
Wow.
It's a continuous cycle of exploration and refinement, all driven by these quantum-inspired principles.
So we've got these quantum chromosomes exploring all these different possibilities all at the same time.
Right.
But ultimately, we need an actual solution, one we can use,
Right.
something concrete.
That's where the observation or the measurement process comes in. It's like we're asking those qubits,
Okay.
okay, out of all the possibilities you've explored, which one is the most promising?
So we're collapsing all those parallel explorations into a single answer.
Exactly.
Cool.
When we measure that quantum chromosome, it goes from being in those multiple states to a single state. And that gives us a solution, a classical solution that we can actually use.
So it's like these qubits are doing all this exploration behind the scenes.
Yeah,
And then they just give us the best solution.
exactly. Yeah, they do all the heavy lifting.
That's wild.
And GQAs are just one example.
Really?
There are other quantum-inspired algorithms out there,
Okay.
each taking inspiration from different natural phenomena.
So like quantum swarm evolutionary algorithms.
Yes, QSW.
QSWE, right?
That's
I read that they're inspired by flocks of birds.
Yes.
And how they search for food.
Yeah, it's a really cool concept.
Something about how each bird kind of explores on its own, but then they use the group to find.
It's like collective intelligence.
Okay.
Each bird might not have the full picture, but together they can cover a vast area and zero in on, the best feeding spots.
Right.
We translate this behavior into an algorithm.
So instead of birds, we have these potential solutions, and they're sharing information to try to find the best outcome.
Precisely. And just like with the GQAs, we add in the power of qubits,
Okay.
allowing them to explore a much wider range of possibilities all at once.
So it's like giving each bird a quantum compass or something.
Exactly.
That's a great analogy.
It's incredible how we can take inspiration from nature and then enhance it with these quantum principles.
Yeah, absolutely.
Another type of quantum-inspired algorithm that's really interesting is quantum-inspired firefly algorithms, or QIFA.
Fireflies.
Yes.
Like the bugs that light up.
Exactly. They use flashes of light to communicate.
Right.
And the brighter the flash, the more attractive the firefly.
Okay.
QIFA takes inspiration from this.
So are we talking about algorithms that communicate with each other using light?
You can think of it that way.
Okay.
Each potential solution is like a firefly.
Right.
The brightness of its light, so to speak, represents how good that solution is.
Okay.
And the algorithm simulates those fireflies' interactions, with brighter fireflies attracting others towards more promising areas of the solution space.
So the brighter fireflies, the better solutions, are guiding the others.
Precisely. And once again, we introduce qubits into the mix, allowing them to explore a much richer set of solutions.
It's like giving each firefly the ability to explore multiple paths at once.
Yeah, exactly.
These quantum-inspired algorithms are amazing. What's next for them? We've been talking about them on our regular computers, but what about actual quantum computers?
That's the really exciting part. We're on the cusp of a new era where we can run these algorithms on actual quantum hardware.
It's like we've been giving them all this training in a simulation,
Yeah.
and now they get to go out into the real world.
Absolutely. It's an exciting time to be working with this technology.
That must be so cool for you all, the researchers.
It is, yeah. Although some of these algorithms, especially the ones designed with qubits in mind, they'll probably adapt pretty naturally.
Yeah, that makes sense.
It's what they were, well, kind of made for.
Right. But for others, it might be a bit trickier.
Yeah, some might need a little more, tweaking and optimizing to really unlock the power of quantum computation.
Right.
And we also have to consider the limitations of the quantum computers themselves.
Yeah, of course. They're still pretty new.
Exactly. So things like the number of qubits and how long they can hold their quantum states, those are all factors.
It's about finding that balance, pushing the boundaries, but working within what's actually possible.
Exactly.
So when we do unlock the full potential of these quantum computers, what kind of impact are we talking about? What could these algorithms actually do?
That's the big question, isn't it? The really exciting part.
It is.
This isn't just about, making things a little faster.
Right.
These quantum-inspired algorithms they could revolutionize entire fields.
Okay, like what? Give me an example.
Imagine designing completely new materials.
Okay.
Materials with properties we've never seen before.
Okay.
Leading to, who knows, breakthroughs in energy, medicine, all kinds of things.
Or using them to, like, model climate change, maybe predict the financial market, even develop new medical treatments.
Exactly. The possibilities are, they're pretty much endless.
It sounds like it. It's incredible to think about.
It really is an exciting time for this field.
It's been a really interesting deep dive.
Yeah, it has.
Learning about these quantum-inspired algorithms, how they work, the potential they have.
Yeah, absolutely.
It seems like we're really just getting started.
We are, yeah, just scratching the surface.
So if our listeners could take away just one thing from our conversation today, what would you want it to be?
I'd say keep your eyes on this field. Quantum-inspired computing, it's not just a futuristic concept anymore.
Right.
It's happening now, and it has the potential to really change the world as we know it.
And maybe some of our listeners will be the ones to make those breakthroughs happen. You never know.
You never know. That's the beauty of it.
A future full of exciting possibilities. Thanks for joining us on this deep dive into the world of quantum-inspired algorithms.
Yeah, thanks for having me.
We'll catch you the next one.